Hello and welcome back. This is video number 7 in the question and answer series. In this video, we are going to solve how we can identify compound propositions, symbolize it, and construct a truth table for it. So this question comes for 6 marks. This has come in the previous test papers. This was the actual question which had come. So we have to analyze and work with compound propositions. The problem is the statement that was given was he is clever and he is either rich or lucky. Now the question was to identify the following compound proposition, symbolize it, and construct a truth table for it. So the proposition is he is clever and he is either rich or lucky. Let's symbolize it. Let C, he is clever, R, he is rich, and so how do we break it up? We break it up based on the connectivities, connectives, and or. So and is represented by this symbol, or is represented by this symbol. So C, capital letter we have to use for all propositions. So C represents he is clever, R represents he is rich, L represents he is lucky. The compound proposition can be symbolized as he is clever and he is rich, or he is either rich or he is poor. So this is or, this is and. So this is how we construct it. Now we'll be going through many of the challenging questions, challenging propositions, and converting it into its equivalent symbolic representation, as well as the truth table. So don't worry about it. There will be many more challenging questions coming up. This is going to be a long video and it's a 6-mark question. It is very scoring. This is very, very simple. This reads, he is clever and he is rich or he is lucky. Alright, now how do we construct the truth table? Alright, so this truth table is also very simple. Let me break it down. So we need to evaluate C is clever and he is either rich or is, what did L stand for? Is lucky. Alright. So first we write clever, rich and lucky. And we have this one statement here, rich or lucky. So this is an OR table. Now we need to know about the truth tables. So in the OR, let me open up another sheet. I'll need to digress a little bit to explain the truth table. Alright, so we are digressing a little bit here. Let's look at the OR truth table. So we start with true, that is P is true, or Q is true. When both are true in the OR statement, basically any one has to be true for the conclusion to be true. So this is true. Either P or Q needs to be true for the conclusion to be true. So even if P is true and Q is false, the result will be true. Similarly, if P is false and Q is true, the result will be true. But if both are false, then the result will be false. Now, similarly is the case with the reverse. If we start with the false part, this is false and this is false. Of course, we checked it is false. If this is false and this is true, then it is true. If this is true and this is false, it is true. So this is the truth table. Now this we have repeated twice. We can remove this out. We can remove this out. All right. So this is the truth table for OR. Let's take the truth table for AND. This will change to AND. AND is represented by almost. Let me find the symbol. Yeah. Okay. So this will be represented by the symbol. All right. So in AND, both need to be true for the conclusion to be true. So if P is true and Q is true, then only the conclusion will be true. But otherwise, even if one is false, the result will be false. And of course, if both are false, the result will be false. Similarly, if this is true and this false, we have covered almost everything here. And or both. So let's move back to our original sheet. Alright, so the OR table will check first. So OR table says either R or L has to be true for the result to be true. So we see R and L both are true, so the result is true. Here only R is true and L is false, yet the result will be true because we said any one of them has to be true. Either R or L has to be true for the result to be true. Here L is true, so the result is true. But when both are false, R and L both are false, then the result will be false. Now let's continue with the truth. Again the same thing. If both are true, the result will be true. If any one is true, the result will be true. If one is true, the result will be true. And if both are false, the result will be false. This is just a repetitive part of this. But the reason why we had to do repetitive part here is because we have to do the C part also, the clever part also. So now once we get this statement here, now we have to compare the R or L column with the C column. Now this relation between the C and the R or L is of the AND relationship. This is between them AND relation. So now we have to use AND between C and R or L. Now AND I already spoke. If it is only when both the sides are true, both the columns are true, only then the result will be true. So we see C is true, R or L is true, then the result will be true. If C is true and the RVL is true, R or L is true, the result will be true. If this is true and this one is false, so both are true again, the result will be true. Again, C is true and this is false, so the result will be false because we need both to be true in the AND statement. Now we start with the false statements. We write F 4 times and check. If C is false and R or L is true, then also it will be false. Both need to be true. So here all will be false because here both sides are not true. So this completes our truth table. I'm sure you must have understood this. Do let me know in the comment section if you haven't. I'll explain it in more detail. Now R or L, this evaluates to true. This is the shortcut method. Remember this. This evaluates to true if at least one R, that is if at least one of them, one column that is of R or L is true. Either of them is true, then the result will be true. Otherwise it will be false. Now in this case, because we have AND, both need to be true. This needs to be true, this needs to be true. Only then the answer is true. So this evaluates to true only when C is true and R or L is also true. Now let's look at few test questions for us to solve. All right. These are complex propositions. We have to symbolize and analyze them. Then we'll also look at their truth table. He is either clever or rich, and he is not lucky. This is a similar type, but we have changed the wordings here. Instead of saying he is clever, or either he is rich or he is lucky. We have changed this to this one. Now, sorry, excuse me. So we'll start with challenging tests for symbolization and truth tables. All right. So we have here complex propositions to symbolize and analyze. This will help us to prepare for our exams. He is either clever or rich. So we have or, and he is not lucky. All right. So we put three symbols C, R, and L. Okay. Clever or rich is together. Clever or rich. So they will be together. And he is not lucky. Not lucky. Instead of lucky, we say not lucky. So he is either clever or rich, and he is not lucky. Let's look at the and. Okay, so we forgot the and symbol here. We have to put and not lucky. Alright, let's look for the next one. If he is clever, then he is both rich and lucky. Alright, we have and here, if, and then symbol. So both rich and lucky. So rich and lucky. Alright, we have this one part. Clever is also there. If he is clever, then we will use the implication symbol. So if he is clever, then he is both rich and lucky. Alright. He is clever if and only if he is rich. If and only if is by this double-headed arrow symbol. Or is this symbol. Rich would be R, L would be L, lucky would be L, clever would be C. So we have C, double-headed arrow, and rich or lucky. Rich or lucky. Okay, if he is clever, if and only if is rich or lucky. So this is a positive statement. Let's look at the answer. Correct. It is not the case that he is both clever and lucky. It is not the case that he is both clever and lucky. So clever and lucky will be one. And it is not the case. Not the case that negation that he is both clever and lucky. Alright. If he is not clever, C, rich or lucky, nor means or. So or lucky. Alright. If means implication again. If he is not clever, then he is neither rich, so neither rich nor lucky. So this is the negative. If he is not clever, so not clever means we have to use the negation symbol. Alright. Now this can also be simplified to, if he is not clever, that implies then he is neither rich and nor lucky. Right, we finish off with this topic here. Let's continue with the next part. Okay, let's continue with the construction of the truth tables for the given propositions, which we had earlier solved. So we have, he is either clever or rich and he is not lucky. So he is either clever or rich and This is the AND. He is not lucky. Alright, so first we have to solve this one. So this is an OR. In the OR table, remember we said any one of this is true, then the result is true. So for this C or R, we have true if we have to look at these two columns first for C and R. So if these two are true, then this becomes true. Alright. Next is if this is true, this is false, then also it is true. Next is if this is false, this is true, then also it is true. And when both are false, it is false. Now, next part is we have to also solve for the negation lucky, not lucky. So for not lucky, it is exactly opposite. So if this is true, then this becomes false. Now, if this is false, because we have to use this again category and use the false one. So we have to use all combinations. So this will be true and reverse, true, false, false, true, and so on. Continue, it will keep happening. All this will cover exactly the same. Now we have to now join this and use the AND symbol. Now only when both of them are true, the result will be true. So this will be true, this will be true, this one will be true, rest all will be false. This is how you create the truth table. Alright, next is if he is clever, then he is both rich and lucky. So if he is clever, implication, then he is both rich and lucky. So first we have to create a truth table for R and L, that is rich and lucky. Only when both the statements are true, then it will become true. Thereafter we have to, if he is rich, then he is both. Then how do we compare this C with the implication symbol? Let's check that out. Alright, let's look at the truth table. So we solved R and L first. When both are true, then only it is true here. True, 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 false, true, false. We all false, false. Alright, now how does the implication work in the truth table? What is the rule for implication in the truth table? So I'm digressing a little bit here, and we'll look at the truth table for the implication because I've not done this before. So let us learn how the truth table for implication works. In logic, implication denoted as P then Q is a logical connective that represents the statement if P then Q. It is also referred to as a conditional statement. The rule for implication in a truth table is as follows. If both are true, then P implies Q is true. If both are false, then also it is true. But if the P is true but the Q is false, then it's false. Otherwise, basically the first one has to be true and the second one is false, that is the conclusion is false, then it is false. But if both are false, then it's true. So let us look at it in more detail. When P is true and Q is true, the implication is true because it follows the rule that if the premise P is true and the conclusion Q is also true, the whole statement holds, correct? When P is true and Q is false, the implication is false because if the premise P is true but the conclusion Q is false, the implication is violated. When P is false and Q is true, the implication is true. This might seem counterintuitive, but logically a false premise cannot contradict anything. In other words, if the premise P is false, the whole implication is considered true, regardless of whether Q is true or false. This is because an implication with a false premise is always considered true, vacuous truth. When P is false and Q is false, the implication is true because again, a false premise cannot make the statement false. So the statement false implies false is true by the rule of vacuous truth. An implication is false only when the premise is true. and the conclusion is false. In all other cases, when the premise is false, the implication is true. So the keyword here is to understand is all other scenarios it is true except for when only when the premise is false. Sorry, the conclusion is false. If the conclusion is false and the premise is true, then the implication is false. Premise is true and conclusion is false. So, second scenario, true false, false true, false false. Alright, now let's get back to the original sheet. Alright, so we know in implication now that if the premise is true but the conclusion is false, the implication is false. If the premise is true and the conclusion is false, then the implication is false. So we know for this scenario, because we have already covered this. So for this scenario, C implies R and L. So C is true. So premise is true. So let us look at the false part. So if this is false, this is the second part. This is true and this is false, then only it becomes false. So this will also be false, this will also be false. This will be true because the second part, that is the this is P and this is Q. So the truth table, the second part, second premise, if it's false, the conclusion is false, then the implication is also false. Otherwise it is true. So only when the conclusion is false but the premise is true. So only in this scenario where premise is true and the conclusion is false, then the implication is false. This is how we understand this. So these are the rules that we need to remember. Now let's move on to the next proposition. He is clever. Okay. If and only if. This is the symbol we have to use for if and only if. He is rich or lucky. All in capital letters. He is clever if and only if he is rich or lucky. Now the truth table would be, because we need to solve the R or L scenario, then we will solve the C if and only if scenario. Now I have to again digress because I don't know the rules for double implication. Let me check that out. Alright, now let us look at the double implication if and only if. In logic, if and only if, often abbreviated as if, longer if, is a biconditional logical connective between two statements P and Q, denoted as P double-headed arrow Q. P if and only if Q. The statement P if and only if P then Q, this is how you read it, is true when both P and Q have the same truth value, either both true or both false. And it is false when P and Q have different truths. So the relation between if and only if and the if then scenario is that in if then scenario, that is this symbol, if then, if the premise is true but the conclusion is false, then only the implication is false. But in if and only if, that is double-headed arrow, in this scenario it states that when both are true, that is premise and conclusion are true, or premise and conclusion are false, only when they are both true or both false, then only the implication is true, otherwise it is false. This is the only difference between both of them. You can see here clearly, if any one of them is false, then the result is false, otherwise it's true. That is all we need to know as far as biconditional rule for biconditional is considered. Alright, now let's move back to our original sheet. Alright, so now we know that we have the biconditional rule also, where both are true or both are false, then only this scenario becomes, the implication is true. So here in this case, first we solve this, that is here, and then compare it with the clever part. And this is double implication, which means either when both are true or both are false, then only the result will be true. So here also it will be true because both are true, true, that's it. And what is this scenario? Yeah, this will also be true, rest all will be false. It is not the case that he is both clever and lucky. Clever and lucky. It is not the case that he is both clever and lucky. Not the case. Alright, so first we do negation. Now we need to know negation. So first we solve this for the truth table. We solve this. Let's look at how it is solved. Negation is very simple. So if one is true, then other will be false. If the other is the first is true, premise is true, then conclusion will be false. And if the premise is false, the conclusion will be true. Let's look at the truth table. So we have C, R, L. Now where is the R in this scenario? There is no R here. R is rich, but they have not given any scenario here for rich. Alright, so just look at this. So first we solve C and L. It will be true only when both are true. So we will ignore this for time being. When they are true, this is true. And when we negate, so true becomes false, false becomes true, true becomes false, and so on continuously. So this is the only scenario. So this is very simple. Let's move on to the next one. He is not clever. So not clever. And if then is there, so it is implication, single-headed arrow. Neither rich nor lucky. Nor means or. So R and L. And he is neither rich nor lucky. So again negation. Excuse me. So the truth table would be, first we resolve the R or L, then we negate it. Let's look at the truth table, how it is done. So we have C, R, L, and we are also negating the C1, that is the clever part, and we are also looking at R or L, sorry, and then we are also negating it, and then we are doing implication of this with this negation. And implication we know only if the conclusion is false, that is the second part, then only it will be false, otherwise it's all true. So let us look at this. This is false, then it becomes true. This is false, this is true, then it becomes false. This is what I said, otherwise it's all true. So this is also covered. Again, once again, if you don't understand, just let me know. I'll make a detailed video of this. I think this concludes this topic. Thank you very much for taking your time out listening through. If you want more proposition statements to solve in truth table, because this is a sum which will carry 6 marks, then do let me know in the comment section. Thank you very much.